Thanks, Beth. I'm not sure there's anything else we can add to that. That was a it's going to be a tough act to follow. That was great. It was interesting. I just came back from the city of Austin, where, if you're familiar with the city of Austin, Lady Bird Johnson Lake is sort of their central park to the city. And they've been working on that lake for 20 plus years in terms of making it a park around the lake. And now what they're doing is they're looking at Waller Creek, which flows into the lake, and ways that they could begin revitalizing Waller Creek and that sort of extension out from Lady Bird Johnson Lake. And I think that's my sort of main talking point today, is that while we need to place a lot of emphasis within Central Park and the woodlands, we also need to be taking a look outside of Central Park and how Central Park is connected to the region and to the ecological systems that support the region. And it was heartening to hear, I think, one of the questions on the last panel that was alluding to that, that how do we begin thinking about these as sort of nested, scaled ecosystems that when we interact with one, we affect the others and vice versa. And last night at the reception, I was talking to Charles, and I said, you know, this is really hard stuff. And he said, yeah, it is. And so I kind of went back to who I like to quote, and that's Otto Leopold. And he basically said, a thing is right when it tends to preserve the integrity, stability, and beauty of the biotic community. It is wrong when it tends otherwise. And I think that even if we're talking about a constructed, somewhat artificial woodland within Central Park, or we're talking about a more natural ecological or ecosystem, that quote holds true. We all sort of grew up in many ways with our eastern deciduous forest, but they have gone through profound changes in the last 100 years, as we heard from some earlier speakers today. Beginning with the chestnut blight and continuing today with the green ash borer and other diseases that are setting in. And in fact, our kids and our grandkids won't recognize the eastern deciduous forest that we know of today, that it's changing that rapidly. And so that poses a whole bunch of questions, I think, and we need to really think about the whole philosophy of what it means to restore, what it means in terms of restoration. And I think over the past years, most restoration ecologists have hung on to this idea of historic fidelity, that we need to look back in the past in terms of restoration and think about how we're going to restore an ecosystem for the future. And I think what's happening now is most restoration ecologists have abandoned that philosophy and have basically said what we need to be doing is restoring for the future, because there is no way to go back to the past. And while historical fidelity is important because that's the only thing we know from a science standpoint, that we need to be sort of moving forward beyond that. As also was talked about earlier today, I mean, we've seen a profound change in our forest cover throughout the United States over the years, this being virgin forest. From 1620 all the way up to the present day map, where very little of it is left, except for hopefully on the banks of the Bronx River at the Botanical Gardens. So that's good to hear as well. But climate change is certainly influencing, and this just shows forest type and how forest type is going to change due to climate change, or how it's actually beginning to change now. And so that's also going to affect the eastern deciduous forest as we know it today, from what our grandkids are going to know it in the future. And then obviously invasive species. We're all aware of invasive species and the impacts that they're having on our forest. Central Park's woodlands are no exception. Invasive species are running rampant around the globe. And not only are they beginning to change the plant composition of these forests, but they're starting to have profound changes on the soil chemistry and biotic wildlife species, the fauna that exist in these areas. So along with climate change and invasive species, we're again wrestling with the idea of when we talk about restoration, how do we do restoration in a way that that looks at invasive species and looks at climate change and says, how do we need to be more resilient versus restoring the past? I call this habitat to nowhere because most of our ecosystems, and especially our forests, are being fragmented. They're being sliced, they're being diced, they're being paved over, they're being isolated to such a degree that actually parks are becoming refuge, or they're becoming patches of forest that are left in the landscape that maybe we need to take a second look at in terms of their ecological functionality. How are they functioning from a landscape ecology standpoint? How big are these patches? What types of species can they provide for? And what are the connections between these patches to other parts of the landscape? Whether we're talking about wetlands or estuaries or river systems. Is Central Park connected to the Hudson River from a wildlife habitat standpoint? If it's not, how can we think about making it connected to the Hudson River or the East River or Prospect Park or other large patches within the landscape? I think as we move forward in the next 50 years, those are going to be the main conservation questions that we need to be thinking about, because right now our patches are too small, they're too fragmented, and they're not supporting the diversity of species that they once did. There's been a lot of work in conservation biology, the science of conservation biology over the years, on looking at what we call island biogeography and the size of the patch, whether it's a true island or whether it's a patch in the landscape, and how many species that patch can hold, and what are the extinction rates, and how do species migrate in and out of these patches. And so when we think about Central Park and we think about the woodlands, not only are we thinking about the cultural historic fidelity of restoring these woodlands, but I think we need to be thinking about these issues of conservation biology and landscape ecology. And in fact, most scientists right now are saying that we're in the 6th great extinction. That, and E.O. Wilson has said, if all mankind were to disappear, the world would regenerate back to the rich state of equilibrium that existed 10,000 years ago. If insects were to vanish, the environment would collapse into chaos. So we think about statements like that, and we think about how habitat fragmentation is causing the collapse of a lot of our ecosystems in terms of supporting diversity of wildlife species. Eric mentioned, I believe it was Eric that mentioned wolves. And there's also quite a bit of science going on now about the effects of removing our top predators from that food web out there. We call this Trophic Cascades. And much of ecology was built on sort of from the ground up, that we start with photosynthesis and we begin with plants, and then we go to herbivores and then carnivores and predators. And that what regulates these ecosystems is photosynthesis and the beginning, or the sort of bottom-up approach. And now scientists are really looking at this and saying, you know what, our ecosystems are collapsing because of the top-down influences that these predators have on the landscape. And so study after study is now showing, after some of these predators being removed from the landscape for over 100 years, that we're now causing impacts that we could have never dreamed of before. We all know the proliferation of deer. Even the proliferation of coyotes now is actually what many scientists are saying is causing the increase in Lyme's disease, because the coyotes are taking out the foxes, and the foxes would prey on the small deer and keep that population in check, and the rodents. And now the rodents are expanding, and because of that, we're having an increase in Lyme's disease. And so we see these trophic cascades begin to happen, and we're seeing it not only from a terrestrial standpoint, but Jim Estes, scientist, has done a lot of studies with sea otters out in California and has shown the effects of trophic cascades with sea otters. The reason I bring this up is because if we're going to maintain artificial woodland habitat, and we're going to introduce or hopefully set up the conditions right for a suite of species to inhabit those patches in the landscape, then we have to be aware of what regulates those species, what regulates the opportunities for those species to inhabit that landscape. And one of the things that we need to be looking about is this whole food web and how that food web interacts with the vegetation and the whole ecosystem processes, whether it's nutrient cycling or the hydrology. And in fact, out in Yellowstone, when they reintroduced the wolves kept the elk away from the streams. All the vegetation started coming back in the streams and actually improved the streams enough to support trout habitat and macroinvertebrates, the small insects in the streams. And so just by reintroducing the wolf out there, we're seeing all kinds of positive benefits and effects. Not that we'll reintroduce wolves to Central Park, and I'm not suggesting that at all, although that would be the dream someday. But the idea is that as we begin to think about restoration in the woodlands, to know that there are some biotic, there's these cascades that are happening, and there's biotic attributes that we need to be taken into consideration. Columbus was wrong. The world is flat, as Thomas Friedman likes to say, and we're homogenizing our landscape to a great degree. And parks offer an opportunity to buck that trend. And if there are ways that we can take parks in terms of restoration, or what I might call regeneration of ecological processes, and keep it central to that place, then I think that that'll also play in well to the whole restoration process of parks. As E.O. Wilson said again, the one process now going on that will take millions of years to correct is the loss of genetic and species diversity by the destruction of natural habitats. This is the folly our descendants are least likely to forgive us. And I think if we take that in the context of climate change, where we're so focused on climate change, yet most of the population out there doesn't know the loss of species that is happening around the globe, and that how parks can be a major catalyst for reversing that change. Just to take you through a quick little diagram here about restoration and the way restoration ecologists are thinking about restoration. As I mentioned before, we have this original ecosystem, and over time it gets degraded. And historically what we thought was we could go back in time and restore that ecosystem. But we also know that there's planetary and regional ecological influences happening on a landscape that we can't reverse, and we have to live with. And so really what restoration is about about moving forward to what that original ecosystem was, but on a trajectory based on what's happened since the time it was degraded. So it's really about moving forward in time, not moving back in time. What we're discovering now is there's sort of these thresholds, these abiotic, what scientists call abiotic and biotic thresholds, which some ecosystems have gone over these thresholds, and there's almost no way to get them back. And what we're looking at now is these ecosystems called novel ecosystems or new ecosystems that are actually harboring a suite of species, fauna and flora, that have come together at an accelerated rate that we've never seen before on Earth. There's no analog to them. So we have no way of going back in time and studying an ecosystem and trying to figure out how they work together and how best to, quote, restore these systems. We also have changing cultural values that influence decisions about these novel ecosystems. And in fact, some scientists say that over 40% of the Earth is now composed of these novel ecosystems. So here we are thinking about restoration ecology or conservation biology in terms of restoring these woodlands and applying good science to it. But all of a sudden we're faced with really no good, strong analog to base our decisions on. So what do? There's conceptual models being developed now about looking at this, looking at the biotic composition, the abiotic conditions of an ecosystem, how we've gone from a historic to a hybrid to a novel ecosystem, and what it's going to take to either work with that novel ecosystem to preserve ecosystem processes or to preserve biodiversity. There's a very strong argument out in the scientific community now where some purists are saying we need to go back to those historical conditions to the best that we possibly can, because that's the only way to save biodiversity. That's the only way to save our biological wealth of this planet. And others are saying, well, you know, we need to have a resilient ecosystem, which means that the ecosystem functions that ecosystem provides, whether it's clean water or healthy soils or fresh air, needs to take place. And so we need to do everything we can to work with our existing novel ecosystems to make sure that happens. And then there's others out there that are saying, no, we need to do both. But how do we do both? And I'm not quite sure we have all the answers to do both. But it's interesting to think about this within the context of Central Park, or any urban park for that matter, that we are dealing with novel ecosystems. We are dealing with really no analog from a scientific basis. So how do we begin then collecting data, analyzing that data, finding the patterns within that data to make sound management decisions in the future in terms of restoring some of these ecosystems? We can go back and look at attributes of forest ecology, or whether it's composition, whether it's the structure of the forest, or how the forest functions. And all of these are very important concepts that we need to continuously think about. And when we think about the Ramble and we think about the North Woods in Central Park, we need to be thinking about these attributes of forest ecology, or maybe, as Beth would say, woodland ecology in this case. And we need to think about them in terms of what's happening now on the ground, what's going to happen in the future based on certain conditions, climatic conditions, or ecosystem processes that affect that, or cultural conditions. How might management regimes or decisions about how that forest should look or how that forest should function in the future will play an important role. So I think the role of landscape ecology and conservation biology in ensuring a resilient landscape is really important, not only for Central Park, but all our parks across the nation. And then how can the science of landscape ecology and conservation biology make urban parks more responsive to forest fragmentation, loss of biodiversity, and long-term resilience? So how do we balance that with the cultural aspects of what we're trying to do in these parks? You know, there's lots of science out there, emerging science and good science, about ranges of, in this case, minimum patch size for different types of flora or fauna and what is required. We can begin applying some of that science to these urban areas. There's long-term ecological monitoring going on in Baltimore, and I believe out in Phoenix, Arizona, on looking at urban ecology and how urban ecology is working in our major metropolitan areas. And so we can begin mining some of this data and mining some of this science to begin applying to the restoration. And with corridors as well. Not only do we have patches, but we have corridors, and what is required of these species to move through these corridors. And when we think about Central Park, we need to be thinking about it, I think, in a nested scale. We need to be thinking about the woodlands themselves, and even going down from there to individual patches within the woodlands, but then we need to be thinking outward as well. The woodlands within Central Park within Manhattan, Manhattan within what I would call the Hudson River bioregion. And how do we work within those nested scales, or thinking about it from a whole systems perspective? I threw this slide in here after I heard some of the comments this morning, but there is and the reason I threw it in here is because the Wildlands Network, I'm the president of the board right now, so I want to throw in a plug for them. But the Wildlands Network is about restoring connectivity and carnivores across the United States on a continental level. And they've got several programs underway, one out west called the Spine of the Continent, but more directly here they have a program in the east on the Eastern Wildway of reconnecting habitat all the way from Florida up to Canada. And there's no reason that Central Park and other urban parks shouldn't be a part of these wildways that these ecologists are contemplating, because they are going to play a major role, and I think that urban areas have a major role to play within wildways. And in fact, this is a map of what we would call naturalness, and the black areas are more natural than the white. And of course, out west, as was mentioned earlier, there's a lot more public land, a lot more, quote, natural area than there is in the east. But it was interesting, through some computer mapping, some corridors were established of the easiest way for a wildlife to move across the United States on a continental scale. And we can see going up through New York that there are some ways for wildlife to move. And any ways that we can help facilitate that through what we do from a park standpoint, I think would be very worthy. Now, we've worked on parks. We've worked on Pittsburgh parks, doing a natural areas management plan for the city of Pittsburgh for their parks, and we've taken these concepts of landscape ecology and conservation biology and restoration ecology and applied them to how they not only restore their parks, but how they manage their parks in the future. And Fairmount Parks is doing that as well. We've been working with them for years on ways to introduce the concepts of restoration and landscape ecology in their parks, and how can they then fit that into a major green infrastructure program that's going on. Here in New York City Department of Environmental Protection is undertaking a huge green infrastructure program. And that green infrastructure program can be the catalyst, or could be the way to maybe connect Central Park to the Hudson River or to the East River. So I think we do need to be thinking outside the box, outside of the boundaries of Central Park, and how to make those woodlands more vibrant, more resilient in the long run, and making them, or connecting them up to these other ecosystems is one way to do that. Here in Chapel Valley, North Carolina, we took the same type of approach to this woodland here, where we went in and we mapped the woodlands from various ecological attributes, and the site is outlined in yellow, and you can see some of these patches here just signifying different types of habitat. But one of the things we did is we stepped back, and that yellow outline in the middle is the site, but we took a step back and we looked at all the corridors from a landscape ecology perspective of how they interact with the site. And we were able to then look at that from an internal standpoint, look at what we call interior forest, where interior dwelling species reside, which are very important and we're losing throughout the East Coast. And we've looked at corridors and how to maintain those corridors or reconnect corridors up to these urban patches. And so, again, the same thing could be considered from a woodland standpoint in Central Park. The whole idea of reintroducing species and reintroducing species in a way that restores natural processes. The beaver, again, mentioned earlier today, it was a great manipulator of the ecosystem and was considered probably a keystone species because it provided so much habitat for other species. So in this case, in a park, how can we go in and begin daylighting a stream and restoring what was once there in terms of beaver ponds? And so we've learned through applying the science of fluvial geomorphology and looking at hydrology and hydraulics and looking at soil science and looking at landscape ecology and looking at biology to begin figuring out how to re-daylight these systems and restoring these kinds of meadows in these landscapes in a way that not only from an aesthetic standpoint looks great, but from a true ecological functioning standpoint really works and really stitches the ecosystem processes that are happening on that landscape back together again. So the idea of applying science, good science, to the restoration process, I think is critically important. And even in the fact here we're getting these our rare pitcher plants coming back to the landscape, ones that we didn't plant, but ones that were buried in the seed bank and have come back over time. But artificial landscapes are still something to look at in terms of regenerating ecological processes. Maybe we don't use the term restore because we are really regenerating. In this case, this is a dredge spoil site out in Lake Erie next to Cleveland, and these trees, this forest has grown on this site out of pure neglect. But now it is one of the major stopover areas for birds flying across Lake Erie. And so the idea of clearing this forest or manipulate it in any way to interfere with that habitat for for the flyway for these bird species is unthinkable. And so how do you think about going in this case, and providing recreational opportunities here in a manner that not only provides good cultural amenities for the shoreline along Lake Erie for the citizens of Cleveland, but how can you do it in such a way that respects the habitat that has been formed on this island over time to support these migratory bird species? And so using, again, the sciences of landscape ecology and conservation biology, figuring out what the patch sizes should be, figuring out where people can go and maybe where they should be limited to in order to enhance the biological diversity of this site is something that played very prominent in this type of work. And then finally, looking at riparian systems and how they are affected in urban areas and how they play a role in restoration in terms of parks. This being the city of, this Frick Park in the city of Pittsburgh, and this is 9 Mile Run, and 9 Mile Run has a very urban watershed. Unlike the streams in Central Park, this is a natural stream, but it's been degraded over time due to poor water quality, due to sedimentation, due to all kinds of urban influences. So the idea here is to go in and reestablish a river or stream channel here that works with the hydrology and hydraulics of the stream, works with the sediment transport systems, works with the fluvial geomorphology of the river system itself. And so we're applying good hard science to this to make it as resilient as possible, where it still is subjected to those urban flows, but in a way that we're using sound ecological principles to restore this system to what it looks like today. And so what really, for us, the proof here is, what did happen there? Might have these in here twice, I apologize. What happens is that we went from, in 2000, we went from approximately 5 species of fish and 89 fish total that we collected, all the way to 2007, where we went up to 9 species of fish, almost doubling, and close to 760 fish. And so that was a 10-fold increase in the number of fish. And so we've really enhanced the biotic community here as well. But we've also given the residents of the surrounding neighborhoods and the people of Pittsburgh a park that is ecologically resilient in the long run. And then even thinking about, in this case, Philadelphia and Pier 53, and ways of revegetating or, quote, restoring or maybe regenerating ecological processes here, that we know that we can combine the disciplines of ecological engineering and restoration ecology to come up with solutions like this. And even taking our infrastructure, while not germane directly to Central Park, again, thinking about infrastructure outside of Central Park and how we can begin thinking about this aging infrastructure and how it could be reconnected to Central Park, in this case as a wetland filter, and revitalizing the aquatic community of the bay here. And much work is going on right now in Jamaica Bay on reestablishing oyster reefs and reestablishing mussel beds and submerged aquatic vegetation to bring back Jamaica Bay. And the same thing can be thought about in terms of Central Park. How do we make those connections as well? And finally, how do we bring art into this? How do we bring culture into this? This is what you're looking at in the background is actually a wastewater treatment plant for a school. And these kids are out there having art class on these walls next to the wastewater treatment plant. We worked with Andropogon on this, where we provided all the science and did the wastewater treatment plant work, and Andropogon did the design. But it's amazing to see that the kids are now experiencing or using this as sort of living infrastructure out there. So to wrap up, I think for Central Park, there's a couple of points I want to make. One, that I think balancing the practice of good science with meaningful stakeholder engagement is really important. And I use the word practice of good science, not just applying science and walking away, because I think it is a long practice, that it needs to be placed, it needs to be put in place, and it needs to be practiced over a long period of time. We've watched these ecosystems degrade over a long period of time. It's going to take a long period of time to bring them back. And even though that we're talking about a somewhat artificial ecosystem in the woodlands, we can still think about it more or less as an ecosystem and how it can be connected to the surrounding landscape. Recognizing that priorities continuously evolve and ensuring that boundaries are clearly defined in terms of these woodlands and how they interact with the surrounding context of the landscape. Maintaining the capacity of the woodlands to provide multiple ecosystem functions, and that's really managing for resiliency. And if we can do that, then I think in the long run we'll see these woodlands succeed over time in ways that hopefully are planned but also unplanned but are successful. We need to reinforce the basic ecological processes of soil formation, nutrient cycling, and primary productivity. And given, again, the fact that we're dealing with a landscape that was landscaped, and we have lost, or we may have lost, some of these capacities, it would be interesting to think about in terms of the woodlands, what really does go into forming, reforming, growing soil, nutrient cycling, and how do we really enhance primary productivity, because that's what's going to make these woodlands resilient in the long run. And then be aware of those abiotic and biotic thresholds that I talked about earlier. They will be thresholds. They will be sort of walls that we'll run up against. And so we need to think about those walls ahead of time and think about, well, if we don't have a full suite of fauna in there at different trophic levels, then how are those woodlands going to be resilient in the long term without that? We need to set clear, measurable objectives. We need to practice what I call, in borrowing from E.O. Wilson, consilience of disciplines. We need landscape architects, we need restoration ecologists, we need fluvial geomorphologists, we need foresters, we need all of what I call the ologies out there to work on these projects, because I think it really takes a array of different disciplines. And we need to obviously invest in people and local institutions and not just the physical infrastructure. We all know that. And to encourage learning and adaptation in time in the management of programs. What we should be doing is practicing adaptive management. We don't have all the answers, and we can't pretend that we do have the answers. And there's passive adaptive management and there's active adaptive management. Passive is basically, let's just go out there and do something and watch what happens and react to it. I think we need to practice more what I call active adaptive management, and that's actually coming up with some theories ahead of time, testing out some hypotheses where we all aren't going to agree on what's going to work out there. So let's come up with some different hypotheses, and let's actively go out and implement those hypotheses in different areas and test them out over time. Because I think that's the only real way we're going to figure out how to deal with these novel ecosystems and make them resilient in the long run. So I go back to Otto Leopold again. A thing is right when it tends to preserve the integrity, stability, and beauty of the biotic community. It is wrong when it tends otherwise. Thank you.